All right, this is 2-3 homework, patterns and nonlinear functions. All right, we're going to do number 1 on the front, and we'll do a couple on the back as well. So let's take a look at number 1. It says a worker's wages W in dollars is a function of the number H of hours worked. So worker's wages, this is the function of this. All right, meaning the hours is my independent, or my X, and the wages is the dependent, or my Y. So just keep that in mind. They're using different letters, but this is the X, this is the Y. Okay, they want us to graph the function, and then they want us to tell whether the function is linear or nonlinear. Now, they're already telling us it's a function. Remember, there's no repeating X's, so it is a function. Okay, they want us to graph it, and then we'll see if it's linear. So I went ahead, to save time for the video, I went ahead and labeled my graph, and you can do yours the exact same if you'd like. The x-axis is hours, because that's my independent. The y-axis is wages, my dependent. All right, so what I decided to do based on the numbers here, every 2 boxes going across the bottom will be, basically every box is 1 on the bottom. 1, 2, 3, 4, 5, 6, and so on. Now going up, I've got to go to 100, so I made every box worth 10. 10, 20, 30, 40, 50, 60, and so on, okay? So I'm going to go ahead and graph these. Now, they did not give us ordered pairs. They gave us a horizontal table. Remember, you can rewrite that table vertically to make it look more like ordered pairs. That's 2, 20. That's my ordered pair. 4, 40. 6, 60. 8, 80. You don't have to do this, but if you're having trouble rearranging it in your head, you can do it that way. So these, the vertical table is just like a bunch of ordered pairs in a list, right? The X and the Y, the X and the Y. So I'm going to go 2 to the right, 20 up. 2 to the right, 20 up. 4 to the right, 40 up. 6 to the right, 60 up. 8 to the right, 80 up. So far, it's looking very linear, right? 10 to the right, 100 up. Is it linear? Definitely linear, right? See the straight edge there? If you don't have a straight edge, you can just use just a regular piece of paper with a flat, with a straight side. Okay, so that is linear. All right, so we graphed it and we know it's linear. Number 2 and 3 will be the same. You'll just graph them, and these are even nicer. They have vertical tables, so this is your X and Y. Just graph those. Let us know if it's linear or nonlinear. All right. We're going to go ahead and do number 4 on the back. What it says here on the instructions is each set of ordered pairs represents a function. So again, they're telling us it's a function. No repeating X's. All right, determine if the function is linear or not. So it's the same thing, but we're not going to graph this time. We need to try to figure it out just looking at the number patterns, okay? So remember, for it to be linear, the number pattern has to be one of adding or subtracting each time. It can't be a multiplying or dividing pattern. You're either adding by the same number or subtracting by the same number each time. So on the left-hand side, I'm going up by 1s every time. Plus 1 to get to 1, plus 1 to get to 2, and so on, right? Let's take a look at the other side. From 0 to 1, it's plus 1. From 1 to 4, it's plus 3. From 4 to 9, it's plus 5. There's something not working here, okay? There is some kind of pattern there, but it is not an adding or subtracting pattern. So this is not linear. That's all you need to say. Okay, do 5 and 6 the same way. If there's not an adding or subtracting pattern on both of them, then it won't be linear. If there is an adding pattern on both, then it will be linear. Okay, so you can do these on your own. Let's go ahead and take a look at number 8, the error analysis. A student says that the function shown by the table below can be represented by the rule y equals x squared minus 1. But they messed up. Okay, so there's some kind of error. we need to describe the error and correct it. So they use this, and they came up with some numbers, some output values that are incorrect. Okay? So let's see if we can plug in the input values into this pattern and get the real numbers that should happen. Okay? If I plug in 0 here, 0 times 0, that's what squared means. 0 times 0 is 0, minus 1 is negative 1. So that part's right. Negative 1 is right. Let's do it for this one. If I plug in 1, 1 times 1 is 1, minus 1 should give me 0. But they don't have 0, they have 1. Okay, let's plug in the 2. 2 squared would be 2 times 2 is 4, minus 1 is 3, right? So that one's right. They got that one right, and they got this one right, but that one's wrong. Okay, let's do this one. 3 times 3. We plug in the 3. 3 squared means 3 times 3, it's 9. Minus 1 is 8. They didn't get 8, they got 5. Let's plug in the 4. 4 squared is 16, minus 1 is 15. So what did they do? They got some of them right, some of them wrong. Okay? It looks like let's look at the ones they got incorrect. This one, and that one, and that one. Okay? So they plugged in their 1. It looks almost like they did 1 plus 1. 1 plus 1 is 2, minus 1 is 1. Here they did 3 plus 3. 3 plus 3 is 6, minus 1 is 5, right? And here, 4 plus 4 is 8, minus 1 is 7. So why would they get adding out of that? Well, they probably looked at this exponent of 2, and instead of multiplying the number by itself, they probably multiplied it by 2, right? So that's the error they made. We corrected it already. These are the correct y values. So we could say instead of squaring, they multiplied the input by 2. That was the mistake. All right. I hope that helps you.